I give you the kazoo ukulele.
Electricity has a long and interesting history, starting as early as the 3rd century BC with hydraulics. Hydraulics is the study of the mechanical properties of liquids. One of the earliest hydraulic innovations, called the water wheel, came from Greece in 3000 BC. The water wheel is very similar to the modern hydrodam in the idea that it converts natural water flow into useful work. This device was used to grind flour, power sawmills, and lift water out of mines. This could be considered the very beginning of the evolutionary chain that has led us to the modern hydroelectric dam.
The hydroelectric dams that are in use today would have been impossible without the creation of the electrical generator in the 19th century. Hydroelectricity was used for the first time in 1878 by an English industrialist to light a single light bulb. Now, over 100 years later, there are over 2,500 hydroelectric dams in the US alone, and that number is constantly growing.
Hydroelectric dams work by converting gravitational potential energy into kinetic energy and then finally into electric potential energy. First, we'll track the movement of the water inside of a hydroelectric dam. Water begins in the reservoir, where it's kept until electricity is needed. It is then pumped in through the intake, located right here, which is usually closed by a gate that can be opened, of course, to allow water to flow. It then flows down this long tube called the penstock. This is where gravitational potential energy is converted into kinetic energy. It flows around this turbine and finally flows out into an outflow river. We'll now talk about the generation of electricity inside of a hydroelectric dam. As water flows down the penstock, it turns the turbine. This also turns the generator, which creates a flow through a wire. It is then put into a transformer where it's converted into high voltage, low current electricity for long distance travel.
Internationally, over 150 countries utilize hydroelectric power for its inexpensive cost to run and how it can easily adapt to the needs of its consumers. The largest hydro dam is the Three Gorge Dam in China, having a capacity of 22,500 megawatts per hour. The largest dam in the US is the Grand Coulee Dam, having a capacity of 6,800 megawatts per hour. In the US, hydropower accounts for 50% of the renewable energy used and 6% of the total energy in America. After the dam has been built, the cost of keeping it maintained is fairly low, only around 3 to 5 cents per kilowatt hour. In comparison to other power sources, it also has a very small amount of CO2 emissions compared to, say, fossil fuels. It, however, still has an impact on the environment, but only for the low cost of one destroyed ecosystem.
Action.
Over 150 countries utilize hydroelectric dams